Good day, ladies and gentlemen. This time I will present our journal, which discuss the automatic garbage classification system using Arduino-based controller and binary tree concept. Before I started, let me introduce myself. I am Danu Azhar Hidayat from Institute Technology PLN. This is Indonesia waste produce from Minister of Environment and Forestry. The following are the results of garbage management achievement in Indonesia from 2019 until 2021. The amount of waste generated in the last 3 years has been very high, reaching 23 million tons in 2021 and only 11 million tons of manageable waste. One of the waste management efforts is to categorize waste by type to clarify which waste can be recycled and which should be included in the landfill, which it will reduce the waste. This is the community behavior in sorting garbage. The following is a survey conducted by KIC, Data Insight Center, in 2020, and the content is the garbage sorting behavior of the community. 49% of people sort their garbage before throwing it away, and 51% of people don't do it. In this content, people sort their garbage with three ways, namely separate two categories, three categories, or four categories. The more categories, the less people do it. This is an effort of one of efforts of garbage management. Below is pile of garbage. Garbage piles can be reduced through garbage management, include sorting garbage. Various type garbage can be recycled into useful items. So this is a government initiative to make it easier for people to sort their waste. This is sorting bin. The sorting bin spawned the idea that bins automatically sort garbage. This is the idea. The idea is called an automatic garbage classification system. This tool can classify and sort metal, inorganic, and organic garbage. This is the components. Here, this component use these tools using Arduino Mega as the microcontroller and using three sensors. They are inductive proximity sensor, capacitive proximity sensor, ultrasonic sensor, and the servo motor as the actuator, LCD as the display, buzzer and LED as the alarm when the bins are full. This is the binary tree concept. This tool applies the concept of binary tree with only two possibility of decisions. So the system only have two possible decisions when it works. This is the block diagram. Sensor component are input that determines the output response. Inductive proximity sensor as metal detector, capacitive proximeter as organic object detector, and ultrasonic as object appearance detectors. This is the input and output from block diagram. This is the schematic designs and the result of the tools. This is the schematic or wiring diagrams. And this is the result and design. Each component in this tool is tested for each characteristic to be applied to the tool. Below is the test of ultrasonic sensor. This sensor is expected to detect the presence of approaching object. It should be tested when measuring distance. To measure distance, the sensor needs the correct formula. And this is the formula. After the formula check the validity, the sensor will test the accuracy when measuring distance. This sensor has hard time when detecting objects that are too close, so the error is very high. The farther objects, the more errors approach. like this. And this is the proximity inductive sensor performance. The sensor tests to detect metallic and non-metallic objects. The sensor successful detect 7 objects with no any errors. And the sensor can detect objects up to a distance of 8 millimeters. And this is the proximity capacitive sensor performance. The sensor cannot detect dry organic object like dried leaves. This is the fail test of this sensor. So the sensor has one failed when detect 7 objects with for include 4 organic object, sorry, 5 organic object and 2 inorganic objects. And this sensitivity, the sensor can only detect up to 4 millimeter away. This is the servo, the adjustment of rotation angle of the servo motor. The selected the selected rotation angle marked with a scale. This is automated door and sorter servo. We have two sorter servo. Here is the overall system test. The door of the store will automatically open when a person approaches in front of the ultrasonic sensor, so that person can put the trash into the tool. And this is the image of automatic door when it closes. Here is when the person put the garbage into this tool, garbage will detect garbage detected in the first sorter by an inductive proximity sensor. If a garbage is a metal, the servo motor will rotate 180 degrees and drop the garbage into the metal bin. And if the garbage is non-metallic, the servo motor will rotate 0 degrees and the garbage will fall into the second sorter. And in the second sorter, garbage will detect by capacitive proximity sensor. This is the second sorter. And if the garbage is organic, the servo will rotate to 0 degrees. Garbage will fall into organic bin. And if garbage inorganic, the servo motor will rotate 180 degrees. Garbage will fail into inorganic bin. So this is the work principle of this tool. This is the LCD display. This is initial view, and this is when detecting metal, when detecting organic, and when detecting inorganic. This is LCD display when the metal bin is full, organic bin is full, and inorganic bin is full. LCD display will always using bahasa to inform. This is the alarm system when the bins are full. So the buzzer and LED will turn on. The LED has a color in every bin. This tool will test with enter 3 different garbage and has a success rate 86% and 13% failed. And during the test, the organic garbage failed 3 times and the inorganic garbage failed 1 time. So the success rate of this tool is 86.6%. This is the conclusions. This tool has applied the concept of binary tree and sorted garbage automatically. This tool is designed and built using Arduino Mega as a sensor, actuator, and display components controller. This tool has success rate in sorting garbage of 86.6%. And this is the end of the slides. Thank you so much for your interest and attention. See you.